stealth technology, the internet, GPS in the palm of your hand, autonomous operation.
Technology is a driver of our times. Since its founding in 1958 in the midst of the Cold War, DARPA, the Defense Advanced Research Projects Agency, has been a driver of technology. Welcome to Voices from DARPA, a window onto DARPA's core of program managers. Their job to redefine what is possible. My name is Ivan Amato, and I'm your DARPA host. Today, I'm pleased to have with me in the studio Major Christopher Orlowski, a program manager since 2014 in DARPA's Tactical Technology Office. He comes to DARPA with an extraordinary combination of academic, field, and managerial experience and skill sets. On the academic front, he has a hat trick of engineering degrees, a bachelor's in mechanical engineering, a master's in astronautical engineering, and a doctorate in aerospace engineering, the last one from the University of Michigan. His wartime experience includes a deployment to Operation Iraqi Freedom as a tank platoon leader. He has served as the officer in charge and science and technology advisor for the Joint Robotics Repair Detachment at Bagram Airfield in Afghanistan. There, he planned, led, and coordinated personnel training and fielding and sustainment of 3,500 robotic systems. Before his tour in Afghanistan, he served as chief military scientist and engineer for ground vehicle robotics at the U.S. Army Tank Automotive Research, Development, and Engineering Center. At DARPA, all of this previous experience has channeled into a wide range of interests and research efforts, including manned and unmanned teaming in complex environments, biomimetic unmanned systems, and technologies to improve the capabilities of dismounted warfighters on the ground. Major Chris Orlowski, thanks for spending some time with me in the studio today.
Good afternoon, Ivan. Great to be here.
So before we talk about your programs here at DARPA, I want to find out a little bit about you and your background and how you got so interested in engineering.
Yeah, so I think part of it is I had a grandfather he worked as an engineer on the Apollo program. Later, he ended up being, I think he was a vice president at Lear Siegler. So he's always grown up around that type of thing. He was in the Air Force. One of my uncles also was an engineer, so at a young age, I was exposed to it. My grandfather was pretty cool. He'd let me play with his computer. He'd let me work in his workshop. He let his 5-year-old grandson work on his MS-DOS computer and try to figure out how to break it and use it.
Okay, and for those younger listeners, how would you describe MS-DOS?
My best way to describe it, I haven't used it in years because I don't think anybody has, is, or not too many people anyways, is a command line operating system. So if you wanted to change folders or execute a program, instead of just clicking on a drop-down menu or double-clicking on an icon, you actually had to know command lines and where to find things and type out whole command scripts. Of course, I think my computer programming skills probably plateaued from about 5 until I was in grad school, but... Right.
It's just kind of amazing, though, to think of you at the age of 5 tapping away at one of these sort of early iconic operating systems for some of our old computers, which took up, at that time, I guess, half of a desk. So I'm wondering, then, how did you first learn about DARPA, and then how did you kind of end up here as a program manager in the Tactical Technology Office?
So the first time I heard about DARPA was actually playing the video game Metal Gear Solid, where you actually rescue the DARPA director at one point in the game. I had no idea what DARPA was until you did that, and I looked it up and was like, oh, that's pretty cool. But my first real exposure was a previous program manager, now retired Lieutenant Colonel Joe Hitt, had come to TARDEC. One of my jobs at TARDEC when I first got...
For the listeners who don't know, TARDEC stands for what?
The U.S. Army Tank Automotive Research Development Engineering Center. When I was there, I went to a Legged Squad Support System review meeting, actually, the LS3 program review meeting out in Waltham, Massachusetts. It was one of my first things I did when I got out of grad school. I met Lieutenant Colonel Hitt there, and then later he came and he briefed a new program concept to my organization. I had moved on after that to the Robotics System Joint Project Office, which doesn't exist anymore. But at the time, it was the primary organization that fielded and programs of record for robots, and he briefed some program concepts there. So that was my first kind of major experience in how DARPA programs and the scope and complexity of what they do and what their goals are.
Mm-hmm. Can you just take us a little bit further along the pathway? So you had heard about DARPA from this individual, and then how did you end up getting an offer to even work here?
Yeah, so in addition to Lieutenant Colonel Hitt, I had some coworkers in Michigan at TARDEC who were recommended to talk to another Lieutenant Colonel, Nathan Wiedemann. I guess they viewed my background and some of my, I guess, what they claim technical expertise, and recommended something I should look into. So one day took it upon myself to reach out to both Lieutenant Colonel Wiedemann and Lieutenant Colonel Hitt. They were both still PMs at the time, so I asked them, what's that golden path? How do you get to DARPA? Because I had assumed at the time that I was a major, still am, that you needed to be lieutenant colonel to take this position. And the next thing I knew, I was emailing my resume and what's called the officer record brief. And within a month, I was on the phone with Dr. Towsley, who's the Tactical Technology Office Director, and had a phone interview.
All right, well, I'm sure that Dr. Towsley and everyone else you spoke with associated with DARPA was really impressed by your experience and career in the Army. So can you tell me a little bit about that and how you think that might have played a role in getting here? And certainly we'll talk about that and how that played a role in the programs that you are now running.
Absolutely. I think one of the things that leapt out, or at least what I've been told, is the experience with robotics with the Army. So in graduate school, I did some classes, so I had a high understanding of how they work, how they move. I spent some time a little bit of time doing research at the Tank Automotive Research Development Engineering Center before I went to Afghanistan in 2012. I spent about 6 months there, and I did various things. And in addition to being the officer in charge and being responsible for the people and all the robots, I pushed what we call a Joint Urgent Operational Needs Statement. So there was a requirement, shortened it's JUONs, for small robots to support dismounted operations. And so one of my main duties was to support fielding those robots to support what's called a FOA, or a Forward Operational Assessment.
And you had to take a class in remembering acronyms, right?
Right, absolutely.
Yeah, of course.
But the cool thing was before I went I went through the same training regimen, or most of the same training regimen that we, at the time, the Robotic Systems Joint Project Office did to train the technicians. So I got trained on how to operate all the robots. I got trained to fix some of them, which was kind of uncommon for a major to do that. That's not typically our jobs, but it gave me a better appreciation of the systems, what their capabilities were, what their limitations were. And then when I got into theater and was supporting the operations, I was able to make relationships with various units and get the systems out to a wide variety of units. And as much as I could, I would travel around to smaller bases from the larger bases and go and sit down and talk to soldiers, Marines and sailors, and ask them how they were using their systems, what the capabilities they saw, what the limitations they saw were, and how we could help to improve them.
Wow, that's absolutely fantastic background, and one that's particularly valuable here, I know, at DARPA, because one of the great challenges of the whole institution is to make that connection between, the R&D, some of it very rarefied, and of course it gets applied, but then even when that is successful, to know really what the issues are once you're on the ground, once you're fielding these kinds of technologies, absolutely, it's invaluable. So I actually want to kind of talk about your programs now. You have 3 of them in your portfolio, and all of them associated with empowering warfighters on the ground, both as individual warfighters and as elements of ensembles of human, robotic, and vehicular teams. So let's start with your oldest program. It's called Warrior Web, which to me almost sounds like a quest for a full-body undersuit that can enable warfighters to essentially perform sort of like superhero in training capacity. I know that's simplifying things, but how would you describe the Warrior Web program and its status?
The Warrior Web program, the goal is to reduce the fatigue of soldiers carrying heavy loads. And by reducing fatigue, by doing that, you can implicitly, or at least our goal is, reduce the chance of injury. So when you
and just one question, I mean, when you say heavy loads, you really mean it.
I absolutely mean heavy loads. Our soldiers today in Iraq and Afghanistan are carrying loads of up to 120 or 130 pounds. They're carrying those up heavy. They're carrying those up steep slopes on mountains, and it's not something new. I like to joke now that there's no really new ideas anymore. We're just trying to figure out a better way to do things sometimes. I had the opportunity to go to the Chicago Museum of Science and Industry last year.
Great place, yes.
And well, one, to see the DARPA exhibit that was there, and the other part was just to take my kids there. And they had a exhibit about the terracotta army from China, and the same thing, that they had the same issue when dismounted soldiers go in a fight. 2,000 years ago, they were carrying 80 pounds, and they had specific groups of soldiers that would carry less, so they'd be faster and less fatigued.
And you could see that in the ensemble of terracotta soldiers there.
They could see it, and they had signs set up to talk about it, and I was not surprised. So we have the same problem today. So the Warrior Web program is like, we have the same issues, we're trying to do something different. Is one approach that's been taken in the past, and what DARPA did, and DARPA funded an Exoskeleton Program in the mid-2000s, It looked at if I create a parallel skeleton and I can just transfer load to the ground, and then it takes the weight off the soldiers. But the challenges with that were now if you ever try to walk on a metal plate under your foot, it's very uncomfortable. Those suits actually were hard to operate and increase the metabolic cost or the energy you had to exert to use them. And so they weren't generally accepted for infantry applications where soldiers are moving long distances over tough and challenging terrain. So the goal of the program was to shift to let's look at reducing their fatigue. Let's reduce their energy costs, and then theoretically they could either walk longer with the same and be the same level of fatigue or have the same remaining reserves at a certain point, or they can get to a place and be more physically ready, which is directly tied to how cognitively ready they are to execute their missions. So that's the goal. At this point, the program's been successful. We've met most of our program goals. We're at the point where...
And there were two phases. One was to develop the elements of those, and the other was then to integrate them, right? So where are you...
So we're at the end of the integration phase, actually. So we are done with what we call Task B, which was to build full suits. Harvard and the Wyss Institute in Cambridge, Massachusetts was the primary effort that did that. And we finished testing of those suits with soldiers from Fort Benning, Georgia, at the Aberdeen Proving Ground in June and July. We finished up testing.
Right, and I know one early description or vision of what these might look like is something like a wetsuit, perhaps with lots of higher tech elements into it. But when you look at what is coming out of the program now at this stage, how would you describe it?
I describe it as a great first step, not even just good, a great first step towards producing systems in the future that can be integrated into a larger soldiers ensemble that can reduce their fatigue, allow them to carry loads over longer distances, or even make them try to run faster or cover the same distance in faster time.
But what does it look like when you actually put it on?
So today it looks like a bunch of straps and webbing that goes around your legs, your knees, your hips. There's actuators mounted either on your backpack or your lower back that pull cables that are either connected to your ankle or just behind your hip. And you can walk around and move, and as you move, the system tries to sense how you walk and adapt the best it can to your style of walking, because everybody's different, and provide the best assistance and improvement we can in that manner.
So as I'm imagining that, I'm also thinking there must be a kind of acoustic element to it. I mean, so as you're moving, you must hear things like zit, zit, zit.
There's a quite often sound of the actuators pulling the cables in and then pushing them back out constantly. And we did some really good work. The Harvard team did some great work to actually reduce that noise. And so to the point where by the end of the program, their controls engineers were complaining about the lack of noise because they used to use the noise as a way to troubleshoot the system. So when the noises started setting a different pitch or a different sound, they knew something was wrong. Now it's so quiet that they can't do that anymore, which is a good thing for some aspects.
A good thing in the field, if you're the engineer, it's perhaps a little problematic. You got to be more clever in keeping the improvement moving along. And there was one other thing that I found interesting about the goals of the program, which was that the whole suit would be powered by something like 100 watts. And so, obviously that's to keep from having to add battery weight. And where are you along the lines toward that goal?
We're close. We are still using batteries. We're not going to put a portable engine or something like that on the back of a soldier. But we did come in a little higher than that because we were trying to reach the goal of 25% metabolic reduction. So oftentimes with the DARPA program, you set goals, set metrics that you honestly don't know if they're achievable. You hope they're achievable. That's why we're doing the research to see if we can reach these bars. And come down to a system trade at the end of the program where we could meet the metabolic reduction of 25%. We could meet the total system weight or total system mass of being less than 9 kilograms. But the power draw...
That's about what, 20?
It's about 20 pounds total.
Yeah.
And that included the batteries. But the power draw was higher than the 100 watts largely because we moved to the quieter actuators at the end, which ended up drawing more power.
Okay, fascinating. Well, good luck with continued progress in that program. So I'd like to move now to a second program. This one's called the Ground X-Vehicle Technology, or GXVT program. And just from the look of some of the sort of artist concept images, I can see that this one would have some particular resonance for you due to your experience in Iraq as a tank platoon leader. So tell us about the GXVT program.
The way I like to describe the program is the focus is how to improve the capabilities of an individual ground combat vehicle. How do you make the crew better? How do you make the vehicle itself better? Which in and it explicitly does make increases their effectiveness or increases their efficiency. So our primary foci at this point are looking at technologies that augment the crew, so to provide them more efficiency or effectiveness in their individual tasks, or improving the mobility of the platform, so the platform can either have access to more terrain, so that with the same vehicle weight, same wheelbase, or I can actually move faster and safely and over the same types of terrain.
Right, and I think I read you want these vehicles to be able to access and operate in 95% of the terrain that they might encounter. So that's a huge range of possibilities, right?
Absolutely. And so there's some of those challenges that we've looked at, three main different ways to do that. So there's an age-old, well, maybe not age-old, but at least since the 30s and 40s, there's a constant argument between tracks versus wheels. What's the best application for it? Even manifested in World War II, you saw a bunch of half-track vehicles where there were wheels in the front and tracks in the back. Well, one of the efforts we looked at is we have a reconfigurable wheel track where you could have a wheel and transform it into a track and back again. So if you need to drive on the road, you're in wheels. If you're in sand, soft soil, snow, those types of terrain, you can transform into a track and reduce the ground pressure. I'm
trying to get a sense of this. Is it a single kind of vehicular element that actually will form into a wheel and then reform into a track? Or
Absolutely.
Is there?
Yeah, absolutely. Wow. So it's a wheel and then transforms into a triangular shaped track on demand or as necessary.
It does actually remind one of the Transformer movies a little bit.
Yeah, it does. Yeah, maybe I should tell my kids that I work on Transformers. Maybe they think that's cool. A couple other things we're working there is we've got a suspension effort that's going to result in a full vehicle demonstrator with the goal of driving the standard Army test courses faster than any vehicle in its class has ever driven them. So say a Humvee can take that road at 10 miles per hour. We'd like to do it at 18 to 20 if possible. While not exceeding the safe driver limits. So there's standard limits of how much energy can be put into a driver, hitting bumps, hitting holes, going over rough terrain. And so our goal is to go as fast as possible while maintaining those safe driver limits.
I understand also the program does involve components like sensors, other things that will increase the situational awareness of those who might be inside. Just talk a little bit about some of those components.
One of the things that's a challenge for vehicles is the windows tend to be the weak point. I need to look outside the vehicle to be able to see and operate it, and windows can provide weaknesses. They're usually typically less safe or less dense and have less ability to withstand anti-armor threats like missiles or sabot rounds.
So are you going to tell me you want to get rid of the windows?
That's one of the things we're actually looking at, is getting rid of the windows. Tanks don't have windows. You usually have little vision blocks, but you can't see a lot out of them. So two efforts we've looked at in how to, if you remove the windows, is one is looking at driving from a near to eye or like a heads-up display that takes in stereo of images from around the vehicle and projects them to your eyes. And the cool thing about that is if you ever driven a vehicle by just a screen, there's a thing called the vestibulo-ocular reflex where your eyes expect a certain amount of motion, but the screen doesn't give that to you, and it can make people who are nauseous. So some people are very susceptible to it. Others can kind of train themselves to be less susceptible, but still over 20, 30 minutes, you can get sick, you can get nauseous and not operate the platforms anymore. So by now projecting a stereo image, you can actually reduce that fatigue or almost eliminate the nausea, and you can drive these things for a long time. So I've done it. The group, Honeywell was the company that did it, modified a Polaris platform. You drive it completely black out, and I think I got it up to 35 miles per hour on a dirt track a couple of weeks ago.
With no nausea?
With no nausea.
Well done. Okay. I'm sure there's many more components that are part of the GXVT program we can talk about, but I do want to move on to the third so we can give listeners a sense of all of what you're talking about. The third one is called the SquadX Core Technologies Program, I think known more often just as SquadX. And this one is a systems of systems project, which I'm glad we're going to be able to talk about that because that's something that DARPA is doing more and more of, just from the sound of it, you can tell that this is a very complex kind of pursuit. By system of systems, this is a project of many parts, each of them with their own challenges and complexities, but they're all intended to come together in ways that infantry squads on the ground would then have unprecedented degrees of situational awareness and capabilities and an ability to adapt to complex and rapidly changing situations. Again, we're not going to have time to talk about all of the pieces of SquadX, but it would be great if you give us a little bit of an overview and maybe talk about some of those components that excite you the most. So let's start talking about Squad X.
I think the one best way to describe Squad X is you mentioned systems of systems. We just tend to shorten that to focusing on the squad as a system as a whole. One of my motivating factors for forming that program was experience of talking to company commanders in Afghanistan who asked them to, for feedback on the robots we had provided them and trained their soldiers on. And one came back to me and said, "Sir, we're not using it because we've got all this other gear we're supposed to carry. They're throwing all this individual gear at us, whether it be mine detectors or provides explosive device systems, and we just don't have enough soldiers to carry these things."
So, and just an interesting point here, because we are in a kind of a technophilic environment, so we tend to think that technology is a good thing. But here, what we're learning is that technology has to work and be practical, especially for our warfighters, who have so many things to worry about, so many things to carry. So this was a kind of an interesting lesson for you to learn.
Absolutely, and I think part of it is from at least my viewpoint, is the Army and Marine Corps have done a very good job, especially over the past 15 plus years of war, of equipping individual soldiers. But sometimes what gets lost is if I throw too much at an individual soldiers or Marines, I don't look at what the impact is to a fire team or a squad. So one of the main focus areas of Squad X is to look at, well, what's the effect on the squad's performance? It's the smallest formation in the military that can conduct what we say is fire and maneuver. So they have elements that can fire while the other team's maneuvering on a target.
And just how many warfighters might a squad have?
An Army squad today has 9 soldiers, and a Marine Corps squad has 13.
Okay, thank you.
So that's the kind of size we're looking at. And we're looking at how we can holistically improve them. So in taking a systems approach to do that, looking at the total weight of the squad as opposed to the total weight of the individual person, the total effectiveness of the squad versus the effectiveness of a single person, for example. And trying to develop metrics, which hasn't been done before, to how to quantitatively show we're improving the squad. And to that end, I think some of the coolest things or most potential benefits we have is really truly figuring out how we can integrate unmanned systems into a squad and providing capabilities that don't result in a soldier or Marine being heads down, because if a soldier or Marine's being heads down trying to control a robot, then they're not paying attention, and that's one less rifle that's in the fight for that squad. So a couple of things we're looking at is how we can have unmanned systems, ground robots or air robots, move with a squad in formation. Sounds pretty simple, but in the military, if we can, we maneuver in a formation. We have different formations for different missions and different conditions. So can we get robots to recognize what the squad's doing and maneuver without being told how they're supposed to do that? Can we get robots to maneuver as scouts in front of the squad, to the side of the squad, whatever the most appropriate position would be, so that they can actually provide support?
Right, and again, this is without the human parts of the system worrying about the robotic ones, right? Thinking that they're just going to, in a sense, know what to do, almost as a collective cognitive entity, all going forward.
Absolutely. And then as we do that, some of the other things we're looking into is not just getting the robots to move reliably, but then what useful tasks can they do? So we have efforts out that are can they detect humans? So that can these unmanned systems or cameras carried by these unmanned systems go out and find humans in the environment and report back to the squad that there may be humans over here, and even trying to get to the point where we can distinguish whether or not they're carrying weapons and let the squad know that.
So you've been here, I think, since 2014. Sounds like a tremendous amount of R&D effort, and yet you're also coming to the end of your tenure here as a program manager. That's an interesting aspect of DARPA, in that the program manager role is a pretty short-lived one, anywhere from 2, 3, 4, maybe sometimes 5 years. So it gives you a sense of urgency. But this Halloween is your last day, as far as I know, right? Is that still the case?
That's correct. My last day's Halloween.
Right. So you'll be handing off these programs to your fellow program managers and see if they can take them to the finish line. But because you have kind of the benefit of remembering the beginning, living the middle, and now coming to the end of your program manager status, I think you've got a kind of a good perch for just saying a little bit about the whole experience of being a program manager. What would you say you learned about that role, say, as part of the overall innovation ecosystem in the context of national defense?
I think biggest thing I've learned since being a program manager is that the innovation and collaboration it's a team effort. I don't do it by myself. There's no way I could begin to fathom to manage all these programs and all these efforts that are under them by myself. So I have a great team, a great support team that helps, who are technical experts in the field, in their fields, and that ultimately even us is not the ones that do it. It's the engineers and scientists at the companies and universities and defense contractors that we fund that are the ones that ultimately are going to bend metal and write code and they deliver these capabilities to the warfighters. But I can't forget the warfighters either, because their invaluable advice, recommendations are also part of a loop. So it's a collaborative ecosystem that results in the innovation that provides these new capabilities.
No, that was actually a beautiful way of connecting what is happening in this DARPA headquarters, which is mostly kind of a typical office building, reaching out to the researchers. We call them the performer community. And in your case, you have several for each of your programs. And so you multiply 3 by whatever. I'm sure you've got probably a dozen or many more than that performers out there. All of your work and your colleagues, you have to go out and make sure everybody's kind of doing what we all agreed would happen in these programs. But then you're taking it all the way out into the field. So this really kind of draws the full line. So it's really interesting to hear that. But because you are leaving on Halloween, I have to ask you now also, what's next for you, Chris?
So I'll be assigned to the Pentagon, and part of my duties there will be to take the lessons I've learned at DARPA and take the lessons I've learned in past assignments, especially the lessons learned in Afghanistan, and apply those to problems for the Army where we need capabilities in a timely manner.
Well, okay. Well, it'd be good to know that there's going to be someone who has had a lot of experience here at DARPA and in the field and now over in the Pentagon looking at the whole sort of technology equation in the context of national defense. So thanks for sharing all of that. Chris, you've been here at DARPA, and I often think of DARPA as a place where technologies that are for the moment fictional sometimes become non-fictional or real. I am wondering if you are someone who has been inspired by science fiction in your life, if you've been a science fiction reader, if there are fictional technologies in movies, you've seen some advanced technology on the field in your deployments. Is there fictional technology that kind of you find fascinating and might want to ultimately one day see become real?
There is, actually. I've joked quite often since I've been here that I go mind old G.I. Joe cartoons that I grew up on for technologies that the G.I. Joes had in the early 80s and use those. And they had robots that moved with them and had capabilities to protect the Joes or take the fight to the enemy as necessary. So,
do you have your old comic books? Or
I have the old cartoons still, yeah. I actually rebought them, much to my wife's chagrin.
And so, I mean, it's amazing to me that you might be able to go back to some of these cartoon images that you saw as a child and then compare them to what you are actually doing now and have been as a DARPA program manager.
Yeah, it's been quite fun. It's been a great experience being a DARPA program manager.
Well, Chris, it's been delightful to have you in the studio. Thanks for sharing with us a good part of your experience at DARPA just before you're about to leave on Halloween. So I'm sure your colleagues are going to miss you when you go. But thanks for all that service here. I just want to thank you for sharing this time with me and our listeners.
My pleasure. Thanks for having me.
And thanks, listeners, for eavesdropping on us. I hope you join us again for the next Voices from DARPA. For more information about Major Chris Orlowski, the programs he has been running, and the other breakthrough technologies DARPA is working on, visit darpa.mil. And for links that enable you to download this podcast, go to the Voices from DARPA page on DARPA's website.